should have last written down before we moved on. And so the first symmetry we're going to talk about is x-axis symmetry. Basically, what symmetry means is that's like a mirror image or a reflection. So when you hear x-axis symmetry, what that means is that means like the x-axis is a mirror. And so if you look at this example of a graph, look at how the graph is mirrored around the x-axis. Okay, it opens, and so how you find if a graph has an x-axis symmetry is you replace y with negative y. Okay, that's the important thing you need to get down. Y-axis symmetry, on the other hand, means that the mirror image is on the y-axis, and so that it's kind of flipped on the y. And so if you look here, here's an example of a graph that has y-axis symmetry. How we find that algebraically is we replace x with negative x. And then last but not least is origin symmetry. Origin symmetry, if you notice, it looks like it's been flipped over the y and then the x. Or it could have been flipped over the x and then the y. Because if you think about this, if this first one here has x-axis symmetry, it's going to go that way, right? And then this one will go this way. Well, then now if you take that purple and you flip it over the y, it's going to flip over onto itself. And so that's what origin symmetry is. How you determine it algebraically is you replace x with negative x and y with negative y. Okay, so now let's go ahead and look at this. It says use the graph of the equation y equals x squared plus 2 to test for symmetry with respect to the x-axis, y-axis, and the origin. So let's look at this. What symmetry does it look like it has? Y-axis, right? Because it looks like you could fold it on the y-axis and it will fold on itself. So now what we need to do is confirm that algebraically. So the first answer you're going to write down is y-axis symmetry. Then what you're going to do is, if it has y-axis symmetry, remember the rule was to replace x with negative x. So where do you see x? You see x, y equals x squared plus 2. So now wherever I see x, I'm now going to put a negative x. So I've got y. Oh, I see x, so I'm going to put a negative x in. Well, what happens when you square a negative? It becomes positive. So really, what does this become? X squared plus 2. Does that match the original function? There you have just shown that it has y-axis symmetry. It has to be identical. All right, let's look at the next one. Use the graph to test for symmetry with respect to x, y, and the origin. So looking at that, what symmetry does it have? Origin, or so we think. So we're going to try to answer origin. Now if you remember with the origin symmetry, you were to replace x with negative x and y with negative y. Oh, silly. There we go. We'll make that a y. So my original function is xy equals negative 6. So let's replace x with negative x, y with what's negative x times negative y? Positive xy matches, so it does in fact have origin symmetry. And then this whole thing. Because that's your proof. When it says to support your answer and confirm algebraically, that's this. All right, next thing we're going to talk about are even and odd. So this is one of those things. If you get to college and you have something like this, a chart pull up, you're not going to be able to write down everything on the chart. So we need to figure out what are the important words. Even function, and then what else is important in that sentence, do you think? Symmetric to the y. So if I were writing this down, I would write y-axis symmetry equals even function. Do you see how you're going to just kind of have to look and you're going to have to pick out what's important? So, y-axis symmetry equals even function. What on this next one, what would I write down? Origin symmetry equals odd function. Okay, origin symmetry equals odd function. So basically, an even function is just one that has y-axis symmetry. Okay. An odd function has origin symmetry. Has x-axis symmetry, it's not even or odd. So now, get out your graphic calculators. Notice what it says to do on the board. Graph the function, f of x equals. Okay, now you've graphed before. You've used GeoGebra and you've used the online graphing calculator. Okay, so now you're going to learn how to graph using your graphing calculator. So the very first thing that you're going to go to is you're going to go to y equals. Top left. Okay? Okay, so go to y equals. Okay, now what you're going to do is you're going to enter in x squared minus 4x plus 4 in the y1 equals button. So the x button is located right next to the green alpha key. It says x, t, theta, n. So you're going to do x, and then the squared key is located, that little caret, that little hat by the division sign. So x caret 2, and then you've got minus 4x. You're going to use that same x button plus 4. Okay, now make sure that it doesn't stay in the exponent. Make sure that you move it down. So you're going to have to use like your arrow to move that down. Okay, when you get done with that, I want you to go to the zoom menu, which is located in the top middle. And I want you to hit Z standard, number 6.
X caret 2, and then you get down.
So when you get that entered in, yep, when you get that, just go to zoom, Z standard.
There it is.
Where's zoom to standard?
Okay, so zoom Z standard, and you should notice that your screen looks real similar to what we have up here on the board. Okay, now in looking at that, we need to answer the question, is this function even, odd, or neither? Even, odd, or neither, what is this? Okay, let's rephrase that. What kind of symmetry does it have? What kind of symmetry does it have? What kind of symmetry does it have?
No.
Okay, we're guessing now. Let's use our brain a little bit, okay? X-axis, does it have x-axis symmetry? No. Does it have y-axis symmetry? No. Does it have origin symmetry? No. So what kind of symmetry does it have? None. Okay? So if it has no symmetry, is it going to be even or odd or neither? Neither. Let's look at the next one. Graph the function f of x equals x squared minus 4. So you're going to go to y equals. You're going to type in the x squared minus 4. Actually, what I would do is delete the x plus 4 on the end, and you should be good to go. You don't have to hit the zoom Z standard now, because that's the window that's set. All you can do is go directly to graph now, and it should graph that for you. Okay. So, what kind of symmetry does this graph have? Y-axis symmetry. So since it has y-axis symmetry, is it even or odd?
Even.
Mine's is invalid.
Okay? So, that's what you're going to need to do. Yep. Okay, so now let's look at the next one. Graph the function f of x equals x cubed minus 3x squared. So you have x cubed minus 3x squared, okay, minus x plus 3. Go ahead and enter that in. Remember, all you need to do now is hit graph. Is this function even, odd, or neither? So does this function have x-axis symmetry, yes or no? No. Does it have y-axis symmetry? No. Does it have origin symmetry? No. So what is it going to be, even, odd, or neither? Neither. Okay, so what you need to do now is you need to finish your assignment. Now, and this will be due tomorrow.